Heyo, it's Mr. Otwell, the Math Master, helping you master math, and today we'll be evaluating logarithms. I'm really excited to put our log properties into use. If you find this video helpful, go ahead and subscribe. Go ahead and leave a like, leave a comment, tell me what you think, give me some feedback. Let's do this. So we're evaluating logarithms. Over here on the right, I've written down some notes that we would need to reference for this video, so we need to keep these in mind. The main thing we're gonna do is remember this right here. Our definition of a log, we have logarithmic form here. Log base b of a equals x is the same as b to the x equals a. To help us evaluate the logs, I just find it easier to kind of put it in exponential form to help me think about it, because it's really just gonna provide some insight into what our solution is going to be. Because remember, when we're taking a look at this question, it says evaluate the logarithm. It's asking us to think about something. It's saying 5 to what power is 25? That's what the logarithm operation is telling you to do. So if we just kind of rewrite it in exponential form, it just gives us a little more clarity. So what does that look like? I already mentioned, we said this is 5 to what power is 25. So let's just call that x. It just makes everything a little easier to have some variable or something on the other side of the equation. So what we want to be doing is identifying our a, our b, and our x. Normally we just kind of read things from left to right. So if we read from left to right on this logarithm here, the form that I have, we have log base b of a equals x. The reason I like using b personally is because that's what we call the base of the logarithm. Base starts with B, and then you know what letter is right beside B in the alphabet? A. So I just personally like log base B of A equals X. In other textbooks and stuff, you may see different notation there with the parameters they use, but really it doesn't matter. So our A, in our case, is what's in the logarithm. It's the argument. So what is in the logarithm here? 25. So our A is 25. What's our b? Remember, b is the base. Our b is 5. And the x is what it's equal to. I just made our x equal to x because usually if we're trying to find something in math and we don't know what it is, our favorite variable is x. Now from this point, we just need to take our values of a, b, and x and substitute them into exponential form. Just as a reference, so our eyes don't have to go so far to look, we are going to put it in this form. B to the x power equals a. Our b is 5, so that's going to be the base of our exponential form. This logarithmic form can just be written as this exponential form. So our b is 5, so we substitute that in. We need our exponent, so in this case, our x is just x, and it's equal to a. Our a is 25. So this exponential form just helps us visualize what we're trying to think about. 5 to what power is 25? That's what log base 5 of 25 is telling us to evaluate. We know that 5 squared, 5 to the second power, is 25. So our x must be equal to 2. We know that log base 5 of 25 must be equal to 2. We're just going to do this process for the rest of the problems because I feel like it's a good organized way to just set everything up and go from there. Once you get comfortable with transforming things from logarithmic form to exponential form, really you can skip this a equals b equals x equals business, but I think it's a great place to start. So let's just keep doing that. And once you get more comfortable on your own, I would say you could just skip this little section, this little step here, and then just go straight into moving it from logarithmic form to exponential form and then going from there. So we're trying to evaluate log base 3 of 27, and we don't know what that's equal to. We already talked about how if we just set it equal to x, it makes finding everything a little easier. So we want to find our a, our b, and our x. Once again, reading logarithmic form from left to right, we have log base b. So we have log base 3. So because our base is a 3, our b is a 3. The next letter in our variables is a. So the next thing that comes after the 3 in the expression is 27. So 27 is our a. And then we've already said, hey, we just set it equal to x, so we're going to make that equal to x. So now, once again, if we rewrite our exponential form just off to the side here, it just makes it to where our eyes don't have to go so far to substitute things in. You don't necessarily have to do this part either. I just think it's helpful when you're getting into this Our b is 3, so we're going to put 3 as our base. Our x is just x, so we're going to make that our exponent. And it will be equal to our a, which is 27 in this case. So now this is just a different form of really what we're asking ourselves. Log base 3 of 27 is telling us, telling us to evaluate 3 to what power is 27. So that's just what this says. 3 to the power of x equals 27. 3 to what power is 27? Well, we know that 3 squared, that gives us 9, because that's 3 times 3. Okay, well, if it can't be 2, how about we just check the next one and see? We know that 3 cubed would be the next possible answer. So 3 cubed is just 3 times 3 times 3. So 3 times 3, that gives us 9. And then we have another 3 here. 9 times 3 is 27. Look at that. So we know because 3 to the third power is 27, our x must be equal to 3. So what we found is that log base 3 of 27 is equal to 3. So same thing again with this one. This one looks a little different though, right? We got a fraction going on. So let's think about how we can determine this one. Once again, we just want to set it equal to x. It makes finding our a, b, and x a little easier. Our a is equal to what's in the logarithm. So what's in the logarithm is 1 over 100. Our b is our base. But what's the base if we don't write it? There it is, 10. Yep, you remember from last video. Look at you, working so hard, studying those logarithms. So, as always, in the case of evaluating logarithms, using my method here, x is just going to be x. Let's go ahead and write our exponential form right down here so that we have a quick reference. B is 10, so we substitute that into b. X is x, so we're making that the exponent. And a is 1 over 100, so here is our equation. So we're saying 10 to the power of what gets us 1 over 100. Now this one, we have to think about a little bit more. Our base, it actually turned into a fraction when we raised it to some power. X can't just be some positive whole number like it was up here. What do our exponents have to be if we want to find a reciprocal? How do we make this 10 flip into the denominator? That's where these notes up here are going to come in handy. Remember, x to the negative a power is equal to 1 over x to the a. If we have a negative exponent, that's going to give us the reciprocal and turn that exponent positive. So now we know our x has to be negative something. The only way for our 10 to flip and go down to the denominator is for it to be a negative number for our exponent. So now all we're just thinking about is 10 to what power gets me 100? Well, we know that 10 to the second power is equal to 100, so our x has to be a negative 2. It has to be negative to flip it, and it has to be a 2 to get us from a 10 to a 100. There is our solution. So I hope you're seeing that sometimes when we evaluate a logarithm, we have to keep all of our exponent properties in mind because, hey, our solution might be negative. We have to keep our eyes out for these things. So for this one, we're just going to go about it the same way. Just set it equal to x. Makes finding all of our letters a little easier. We want to find our a, b, and x. So moving from left to right, log base b. So log base 36, our b is equal to 36. Log base b of a, log 36 of 6. So our 6 is a, because that's what's in the logarithm, that's where we find a. And our x is x, because that's what the logarithm is equal to. Let's write this in our exponential form again, just writing this as a quick reference. We want to take our b, substitute it in here. b is 36. So 36 to the power of x, our x is just x, and it's equal to a. Our a is 6. So we have 36 to the x power, and it's equal to 6. Well, our base got smaller, but it didn't turn into a fraction. So our exponent can't be positive because that would make it bigger, and it can't be negative because we didn't get a fraction. So what could our exponent be that actually will reduce the value of the base without making it a fraction? Hey, let's take a look at our notes right up here. Oh, I knew I'd write them there for a reason. Look, if we can remember all of our exponent rules, this one's going to come in handy when we're evaluating logarithms. We need to remember that if you have something raised to a power that's a fraction, it will give you a radical. In this case, I just wrote x to the 1/2 equals square root of x because that's true, and this is the one we need for this. But just keep in mind that sometimes your exponent might actually be a fraction. So if we keep in mind that x to the 1/2 is the square root of x, we could ask ourselves, okay, well, is the square root of 36 6? Yes, it is. So the only way for us to take 36, raise it to a power to get 6 is if x is equal to 1/2. So we know that log base 36 of 6 is equal to 1/2. And if you'll notice, I did go ahead and rewrite this solution rather than just saying x equals -2, just log of 1 over 100 is equal to -2, because that's really what we're evaluating here. We're not solving for x, we're evaluating this logarithm. We didn't have x there initially, that was just my addition. So we just want to write what log of 1 over 100 is equal to, and that's -2. So now we need to scroll down a little bit. Yeah, look at that. Once again, just to help us out, let's set it equal to x. We want to find a, b, and x. And all these, for how I do it, x is x. Our a is going from left to right. We have log base b. So this little guy down here, 9 over 49, is our base. And our a, what's in the logarithm, is a 1. So taking what we know, substituting it into exponential form, we have 9 over 49 to what power is equal to 1? Okay, we're just taking our a, b, and x, substituting it into this. So we have this crazy looking base here, which is a fraction that makes things a little more difficult sometimes. And we're raising it to some power and just getting 1. Well, this isn't as bad as it looks, because we know up here, right, anything to the power of 0 gets us 1. So really, this crazy base doesn't even matter, because this could have been anything. It could have been anything. Anything to the power of 0 equals 1. So we know that our x has to be 0. Therefore, log base 9 over 49 of 1 has to equal 0. So that wraps up our evaluating logarithms video. I hope it was helpful for you. I hope the a, b, and x method is something you can get used to just kind of help you ease into it. If you liked it, please leave me a like and comment down below if that was helpful for you. Hit that subscribe button, that little bell, so you can get some more videos. Mr. Alwell out. Peace.